Welcome to this introduction to grade 12 calculus, and in this we will look specifically at differentiation. I will tell you what differentiation is, then we will look at differentiation from first principles, thereafter we will look at the differentiation rules, the notation, and finally the application of differentiation. It's very important to know this is not supposed to replace your classes you will get. It's just to give you the basics and to give you a good idea of what will be in exams. So that's our focus. And if you want a little bit more, please contact me and I will explain more. Okay. So in grade 11 you guys did average gradients of curves. You are used to getting the gradient of a straight line. This year we are taking it a little bit further and we are looking at the gradient at a point. So you're all happy that the gradient of a straight line is m, which is y2 minus y1 over x2 minus x1, which we can write as f at x2 minus f at x1 over x minus 2 minus x1. Now if we make x2 x plus h and we make x1 x, we get the following. Okay, you can see that we will be left with h only. But this is still an average gradient. So if we're going to calculate the gradient at a point, i.e. the gradient of a tangent at that point, we use this, which is the first derivative, is the limit of this expression when h tends to 0. So it's the gradient that we will find by making h as close to 0 but not 0. Can't make it 0 because then our denominator will be 0. Then this whole fraction will be undefined. Okay. So that's the theory. We will do some practical examples later. Next, we will look at the differentiation rules. There's a few basic ones we look at today. First is the first derivative, and you'll see the ddx represents the first derivative f of x. And how that works is you take the exponent n times by the coefficient and subtract 1 from the exponent. Okay. Then I'm going to start with ddx of k, a constant, which is 0. Now we know that the line y equals to k has a 0 gradient, so therefore the first derivative will be 0. Okay. Then there's an example I will highlight, which is very similar to ddx of k, which is ddx of b to the n. You see that the b is not the same as the x, and therefore it's a constant, which means the gradient is 0. Okay, then a little bit on notation. I already mentioned ddx represents f dash x. Then there's also dx, which we get when we take the derivative of that expression. And another way to write f of dash of x is y dash. Okay. These are the main notations you need to be aware of. Okay. Now to get to application. The first application that we will do is finding the turning point of a graph. So, what do we know at the turning point of a graph? There the gradient is 0, so therefore the first derivative is 0. And we will look at one example. We will try to find the area of a camp, the maximum area of a camp, with limited resources. Okay. So these are the main things that you need to know and will be asked in exams and tests. Obviously, when you have proper classes at school, you will go in a bit more depth. Um, but for my lessons, I just want to give you a good overview, and then we will look at some examples.